Hello everyone, and welcome back to this Words in the World tutorial series on PsychoPy3. Um, in this video, we're going to continue developing the typing task that we started in part 1. So if you remember from part 1, we made sure that the typing routine only ran for trials that were real words. We wrote some code to display typed input onto the screen, and then we fine-tuned that to make sure that it was doing the right things when you press shift, when you press space, exit, return, those kind of things. So in today's video, we're going to start adding some code that will collect the relevant data. So we want to be able to collect response times on these different key presses. So we're going to make sure that we can do that. And then we also we want to check if there are errors or not. Because that will be important for our analysis later on if we're looking at accuracy and, well, we might not want to analyze error trials. So you definitely want to have a way to detect that. All right, so let's go over into PsychoPy. I'm just going to open up the folder on my desktop. There we go. I'm gonna need that later. Here we go. All right. So we've got our instructions, our fixation point, our lexical decision task, and now our typing task. So I'm going to open up the code window here. This is where we're going to do all of our work today. All right. So at the very beginning of the experiment, we're creating this variable, and it's going to be empty. It's called input text. We want to, at the beginning of every routine, make sure that input text is equal, is blank again, because we don't want to display the input text that was collected from previous trials. We had this shift flag that allows us to, well, just makes the shift key work. And then we had this just very short code line that makes sure that the typing routine doesn't run if the trial is a non-word. Okay, so then here we had, we were checking for we were checking the keys that were pressed and doing the right things every time that one of these was pressed. And if it's not, return backspace space or a shift or an escape, then we want to add that key to the input text. All right, so if we want to check how long it took to press each of these keys, we need to have a clock. So I'm going to start that from the beginning of the routine. I'm going to call this clock typing clock, and I'm going to create a clock by accessing the core functions and then running clock. So this will create a clock and start the clock from the beginning of the routine. So now I need to check that clock whenever there's a key press. So I'm going to add something to backspace after this, but for now I'm mostly concerned at how long it took to press the individual letters that make up the word. So I want to have, so if you remember from the from the lexical decision video, we use this this function. So like this experiment accesses the experimental output in the Excel file, and I'm going to add data. So what that does is I can add data to an existing column, or I can create a new column. In this case, I'm going to be creating a new column called typing RT, and I want to save the response time for any typed letter. And so I can do that by accessing the typing clock, and I want to run the function getTime. That's going to look at the typing clock, and whatever the time is in the typing clock, it's going to return that. And I probably also want to know what letter was typed. That might be important. Letter typed. And that's going to be equal to these keys, I. There we go. Now I want to make sure that that I'm adding to I after, because otherwise it's gonna mess this up. I want I to be equal to whatever I was up here. Okay, so that's gonna add that data. Now I have one issue here. So the way that the Excel file works is that a, a new row is created automatically at the end of every trial. That's done by PsychoPy. So every trial it creates a new line. But I need a new line every time that we have a relevant key press. Because otherwise, what's going to happen is I'm going to have this column called typing RT and letter typed, and it's going to get overwritten every time I have a new letter. So the eventual output file will just have one letter in it. I think I might have an example of that from something I was doing earlier. Is it in here? No, that one just didn't work. Must be this one. Yeah, here we go. This is a great example. So you can see that the target was Moonlight. Go away. The target was Moonlight, but all that's recorded here in letter typed is the letter T. Now, at some point during the experiment, this was equal to M and O and O and N and L and I and D and H and finally T, because every time it got overwritten. So I need to basically add a new row for every letter that's typed. So the way that I can do that, oh, another issue here is that this typing RT is in the same row as my lexical response, lexical decision response time data, and that's not something that I want to happen. So I want to separate these out. Let's go back to my experiment here. Oh, I have code open already. So what I want to do is add a new row. So how can I do that? Well, I'm going to use, again, this experiment, and I want to say next entry. So next entry is going to create a new row. This is going to create a new row every time a letter is typed. Now I also want, when we are going from a lexical decision into a typing task, I want to add a new row as well. But I don't want to do that if I'm actually not going to run the typing task. So I'm going to add this inside of, I'm just going to separate it to make sure that doesn't happen. This experiment dot next entry. Great. All right, so this is very nice. I also, well, in my stimuli, there are no words with spaces, there are no capital letters. And exit is just going to exit the program, so I'm not interested in collecting data on those. But I am interested in collecting data on this backspace. So I'm going to insert this in here. And this doesn't need to be equal to these keys because I know it's going to be backspace, so I can just type backspace here. This is going to record the time the latency of the backspace key press. It's going to tell me the backspace was typed. And I'm also going to add an additional entry. Because if I don't do this, then, well, I'll record data on backspace, but then as soon as I get another letter being typed, it's going to overwrite that data on that row in the Excel file. So that looks pretty good. Okay, let's cross our fingers and run it and see if it works. All right, moonlight, non-word. That's a real word. Okay, so let's just exit there and go and check our data file. Oops. Yeah, it should be this one. All right, well, this looks pretty good. So here you can see that every time I add a new entry, it's going to include all of the information from my conditions file that's associated with the current trial. And here we go, this is really pretty. So I've got my lexical decision response information here. I've got my fixation duration. I've got whether I typed A or L. I've got whether it's correct or not and the response time. And here I have the response time for each of the letters typed. Now this is all from the beginning of the routine. So this is going to be aggregating across this. So if you ever want to look at interkeystroke intervals, it's just a matter of minusing this number from this number, and then you'll have the interkeystroke interval between M and O. And that's just something that seems it seems easier to do in Excel rather than having that built into your code. So that looks great. I'm detecting backspaces, and here I can see that there was no backspaces, no errors, and it's looking pretty good. And just like I wanted, when there's a non-word trial, it's not adding any additional rows, it's just going on to the next. It's only adding new rows when it's when there's typing involved. Great. Well, that looks really nice. So now we've finished the first part. Now we want to add something that will detect errors. So let's go back into our code. Okay. So how do I want to do this? So one way you can look for errors is by checking each individual key. So if the word is moon and I type M, is that single letter equal to the first letter in the word? Another way we can do it is look at the kind of aggregated text that's been typed. So you look at input text as a whole, and does that equal to a chunk of the target? So I'm going to do it the second way because that's the reason is that it allows me to do a lot of other fun things later on if I do it that way. So you just have to take my word for it. All right, so I'm just going to open up my conditions file and double check what this is called. So I've called it target. And so in any given trial, I have I have the correct keys that need to be pressed, kind of stored in this variable target. So I can use that. So what I can do is ask, sorry, if input text, like is input text equal to the target? So in this case, I'm going to detect an error. So if input text is not equal to, now input text is going to grow as I type more letters. So I also need this target to, I need to access ever increasing chunks of the target. So I'm going to use, to do that, I'm going to use this variable L. So at the very beginning, so let's just imagine I'm typing moonlight and I type the first letter, so that's M. So input text is going to be equal to M. So if this is not an error, M should be equal to the first letter in target. So I want to take the string target from the very beginning, from the first thing that's 0, and then up until 1. So that basically just says it's only looking at 0 because the number that's here is not inclusive. So if you have 0 to 1, it's just looking at 0. If you have 0 to 2, it's looking at 0, position 0, and position 1. So I want this to be equal to 1. So I'm going to do this at the very beginning of my routine. I want L to be equal to 1. And if this is not true, sorry, if it's true that they are not equal, sorry, then I want to add some data. I'm going to create a new column called error, and I want error to be equal to yes. For some reason, I always forget the semicolon in here. Probably because I'm adding a semicolon, a colon in here. Anyway, so if those two are not equal, we have an error. In any other case, there's only one other case, is that they do equal one another. Oops. If they do equal one another, I want to add data in the same column, and I want to say no. This is not this is not an error. Now I have to do one additional thing, because as input text grows, I also want the chunk of the target that I'm looking at to increase as well. But let's imagine that I just increase L every time I press a key. What if I make a bunch of errors? Well, like the length of the target in the case of Moonlight is just 9 letters. But if I've made some errors and I'm adding to L every time that I type something, I may end up making 11, 12, 13 key presses. And so eventually it's going to try and access the string target from 0 to 13. But that's outside of the range of the target, and it's going to give me an error. So I really only want to be adding something to L when there is a correct key press. So I don't want to do it here. So if input text is equal to that, I want L to grow by 1. Okay, so let's see if this works. That is a non-word, also non-word. There we go, Moonlight. So I'm going to intentionally make an error here. There we go. And I'll exit and go and check my data file and see what that looks like. Okay. So we have our lexical decision task up here, and here we can see that, okay, so moon, that's all right, and it's saying that there are no errors. Then, as soon as I type N, and that is incorrect, it's saying there's an error, then I'm pressing backspace, and then as I start typing again, it's saying that there is no error. So that's great. There are other things that you can do, like well, one thing that this allows you to do is to check for typos, for example. So you can add another line of code that will basically say um, if an error has been detected somewhere in the word, but the eventual input text equals the target, then it's a typo rather than an error. And that might be really interesting for potential analysis, because it's not that you forgot how to spell the word or didn't recognize the word properly or something like that. It's that um, you just had a slip. You have made a kind of motor error in the typing process. It wasn't any kind of failure of recognition or anything like that. So that can be potentially something interesting to look at. Um, let's see. Maybe that's something I'll do. Yeah, that's something I'll do in a future video, I think. Is adding a typo detector. But for now, I don't think that's necessarily very important. So if we just go back and look at what we did here, let's have a look. So we added this clock that's allowing us to record response times. And we learned about how to create new rows in our Excel output file. And we learned how to add response time data into our Excel file manually using code. And we came up with a clever way to detect errors. And I guess just now that I'm thinking about it, just to make that data file look even better, I want to add this additional line whenever we press a backspace. That will just fill in a yes here, because the backspace is kind of an error. It's also a good indicator that there was an error. Again, like including something like backspace, you may even want to put that in a different column, because that's also another indication of a typo, that there was an error, but it was an error that the participant recognized that they made. Actually, yeah. So this is something that I do in a lot of in a lot of my other experiments. Now that I'm talking about it, I'll just show you an example. Um, so this is a bit different because it's in for an entire sentence. Um, but for the sentence, I like to include, is this an error trial? Where was the first error? Was there a backspace? And then at the end, was there a typo or not? So I like to include all of this data, and this is all collected automatically through PsychoPy, rather than having to do a lot of work in the Excel file after the data is collected. It just saves a bit of time, especially if you're looking to analyze data as it's coming in and not in one big chunk at the end. Okay, well, I think I don't have anything else to say about that. All right, so we've achieved everything that we wanted to do in this video. That should definitely be part 2. Um, great. So in part 3, we'll convert everything that we've already written into JavaScript, all of that code, and then we'll try running this online and make sure that it's working. All right, I'll see you then. Thanks for watching.